but the simple thing is you just say, I'm going to clean up my data on the way in, I'm going to clean it up by running it through decode, and I'm going to encode stuff on the way out. And so sockets are the place where this comes into play. And so you'll see we'll always do this encode and decode every time we're sending data kind of outside of Python and inside of Python. So now that we've talked a little bit about character sets, we're going to make this even easier so you don't have to use sockets. URL-lib is a bit of Python code in the library that does all the socket stuff for you. Okay, so now we're going to write a web browser again in Python, but it's going to even be shorter than what we did before. We did it in 10 lines using sockets. Now we're going to do it in 4 lines with URL-lib. So URL-lib really is just because the idea of opening a connection, sending a GET request, sending the new line, retrieving the stuff, breaking the headers out, doing all this stuff, that's so common, why not put it in a library to save ourselves some effort? So here's how we do it. We're going to read it in, right? We're going to import this library, so it's not part, we had to import sockets before, but we're going to import URL-lib now. And so this is really quite simple. It's like elegantly simple. You say, URL-lib, that's a library, that's a part of a module within the library, and this is a function. So let's call URL open, and then give it the URL. Now that's a string which it's going to encode automatically for us. So it's taking care of all kind of pretty things for us. It does the get, it does the encode. Look back at that previous code. That's kind of what URL-lib is doing for us. Okay. Now what URL-lib also does is it makes the connection, encodes the GET request, and then it actually retrieves. At this moment, it retrieves all the headers and keeps them for you for later. You can get the headers, but we're not going to see the headers. And it returns to you an object that looks pretty much like a file handle, because you can put this in the for clause after the in. Now it's going to run that loop one time for every line of this file. And so the lines we're going to get back are bytes, and so we have to say decode. It doesn't do that for us automatically. We are going to have to decode them, and that's because we might need to decode them with a particular character set here. And then we're going to do our strip, and we're going to just print this out. So that's like open a file, read through it, and print it. This is open a URL, read through, and print it. And that's as simple as it is. And so that's what happens. This is romeo.txt, and it prints out. Now the thing to notice is that there are no headers here. The headers have been sort of consumed in the URL open. Again, there is a way to say, hey, give me my headers, but for now, this is just going to eat the headers and keep them, and then you get to read all the data, and the loop runs, and this loop runs 4 times, and out come the 4 lines. You can go ahead and run this one. It's super easy. I mean, literally super easy. And if you can do anything you want. I mean, treat it like a file. You just have to remember to do the decode bit when you treat it like a file. And so that code import it. We're going to open it. We're going to make a dictionary. We're going to loop through. We're going to split it. We have to add the decode just to make sure, because that line is bytes, not string. And then we're going to go, our words. We're going to go through the line, and then each line we're going to bounce through the words. The inner for loop is bouncing through the words, and then we're going to go to the next line, and then we make ourselves a dictionary, and we print that dictionary out. Now this in effect, other than importing this, opening it differently, and doing the decode, this is exactly how we would process a file. And so by using URL-lib, you really sort of reduce the complexity of retrieving and reading network resources to the same complexity of reading and dealing with a file locally on your hard drive, which is kind of pretty. So one of the things then we can do is read web pages. That was a text file, but you can get HTML. And so here's how you read a web page. And it's the same kind of code. We open a URL. This one happens to have HTML in it, and we read through it, and out comes the HTML. Remember that the headers are there, but they've been eaten by URL open for us. And now we could write a browser that would parse these less thans and greater thans and make links, etc., etc., etc. So if you can come up with ways to find these links, you could actually write a bit of code that would then have a loop that would go up and open a new one. Pull out the links, open a new one. Pull out the links, open a new one. And so you could make a thing that would retrieve you could write a program that would retrieve a page, find the links in the page, and then retrieve those links. And we'll actually do that before the end of the class. And so Python is a very popular language at Google, and I wonder if I think it's a pretty safe bet that the first crawler that they wrote to crawl the web, to build the index, was Python, because literally that's all it takes to read web pages and pull those web pages into your web crawler database. So I don't know, are those the first 4 lines ever written to Google? Who knows? So the next thing that we'll talk about is how you handle that HTML. HTML is kind of yucky and nasty, and so it's not as simple as regular expressions. Regular expressions might help, string parsing and split might help, but it's just too crazy. So we'll talk a little bit about how to use a library to make HTML parsing a lot easier. We are going to be talking about some code. If you want to download all the code, it's right here. It's all single big zip file. And all this sample code, the one I'm going to talk about is urllib1.py. It is not very exciting. It's short. That's what's kind of nice about Python code. And it's really, if we go and take a look at the code we played with just previously, which is socket, the idea here is urllib is something that Python has produced for us to make socket communications and HTTP communications a lot better. So socket, this is making socket calls underneath it, but there's a library that makes this quite simple. And so we have to do some imports. So instead of importing socket, we'll import these URLs. We are going to create a handle, URL request URL open, and just pass in a string. So we're not encoding this, we're not sending get command. All the stuff we did in the previous sockets example is gone. And then we can just put this as a for loop. And so we're not using this lower level read and write code, we're just using a for loop. And so that literally is going to read the text line by line. And the line does come back as an array of bytes, so we have to do a decode, but then we got a string, and then we can do a strip on it. So this is like a super simple. So there we go. Now the interesting thing is you also don't see the headers. We just read the contents. Now it turns out in urllib, and we'll see this in later more complex application, you can get the headers if you want. You can get various other things. So that's urllib, a simple urllib tool. Now we can also use this in URL words to show you something quite interesting, and that is, if you look at this from right here, other than the decode, this is exactly the code we wrote to compute the words, right? So other than this line.decode, this is just a open something up. In this case, we're going to open a URL. We're going to create a dictionary. We're going to loop through each of the lines in that thing. We're going to decode them and then split them. So once you do line.decode, this is now a legitimate internal Python string. We split it, we run through the words, and run the counts. And so this is exactly like code that we did before to run counts. And so Python 3 URL words. And so that gives us a dictionary, which is the word frequency. And we could do all kinds of crazy stuff in here, you know, with sorting and all the kinds of things. The important thing is once you've done this and this, the code, other than the need to decode these lines when you first get them, it really works just like makes a urllib makes URLs function inside Python very much like files. So these are short and to the point and very simple, and I hope that they were useful to you. So now we're going to talk about what you would do with a web page once you've retrieved it in a Python program. Call this web scraping. And so web scraping or web spidering is the act of retrieving a web page, extracting the links from those web pages, making a queue of unretrieved links, and then moving on. And eventually the idea is if you had enough time, energy, bandwidth, and storage, you could find your way to most of the web pages on the internet that are point to or are pointed to by other web pages. And so you might have all kinds of reasons to scrape data. You might have a blog that you posted. You might have, who knows, maybe you put some data in a system. Maybe the system's being shut down because it's being retired. You can do all kinds of things. You could write a little thing. I was talking to somebody who wrote a thing to retrieve something and check, and then send a text when something changed. All kinds of stuff. Or you might make yourself a search engine. But be careful. Not all websites are happy about you using a robot to retrieve their content. Some of the websites, as we'll see, demand that you log in and they track what you do, and if they think you're doing something bad, they will shut your account off. Other websites will track what you're doing without you logging in, but then shut your address off. And so you have to be careful. You should read up. You should figure out what sites allow you to scrape them. Now I have some sites that I've set up that you can play with to make it so that it's legit. So parsing HTML is difficult. Some of the simple examples, you could probably write a regular expression, or certainly some splitting and some whatever. And what you would find is you would write that code and you'd retrieve your first 5 web pages and it would seem to work, and then it would encounter some really weird but legitimate HTML, or maybe even sort of slightly broken HTML. So the web is full of broken HTML, and your browsers just look at it and go like, oh wow, more broken HTML. But they don't put up error messages, and so people just leave broken pages up. But your Python program is going to see those broken pages. So what you would do is you'd be like, oh, here's a new weird way to do an anchor tag. I'll change my code. Oh, and then run for another 100 pages and like, oh no, here's a new weird way to do an anchor tag. And the problem is that you're going to find a lot of different ways to mess up an anchor tag. And someone has already done that. There's a software called Beautiful Soup, and we have installation instructions on how to use it. And really what it is it's somebody just spent months figuring out all the nasty things that could happen and compensated for it and gave you a nice wrapped interface that just says, look, you give me the HTML and I'll give you back the tags, okay? And so it's called Beautiful Soup. And so you have to install this. There's a couple of ways that you can install this. If you're good at extending your Python, you can just, extend and install Beautiful Soup for all Python programs. If you can't change your computer's configuration because you're on a school computer or you're using a USB stick or something, then there's a way to download this file that I've created called bs4.zip. And so what you do is you end up with your file called, URL links.py, and then a little folder called bs4, which is a folder that has a bunch of files in it from this zip file. And then you can run it. And so it'll pull it in, and you'll import from BS4 Beautiful Soup, and that's either going to pull it in from the folder you do, or if you have installed it using the Python installer, it will also you don't have to put this file in. So it's up to you. You can either do it one of 2 ways. So this is a little bit of code. Now Beautiful Soup is a complex library, and so just because this looks easy, doing things in Beautiful Soup, you might have to actually read a bit more to figure it out. But we're going to just read this. We're going to import Beautiful Soup. We're going to ask for a URL right here. We're going to take that URL. We're going to open it. URL open. They give the URL and read the whole thing. That means we're not writing a loop. We've read the whole thing. That's okay as long as you know that the file's not so large. And then we're going to pass the data we got back. And this is going to be bytes, but Beautiful Soup knows all about bytes and all about UTF-8, and it figures that out. And you just say, hey, take that stuff I just got and tear it apart using HTML and give me back an object, a soup object. Now the soup object is something that you can run queries against. So it parses it, it deals with all the imperfections and inconsistencies in this HTML byte array. And it fixes that and gives that back. And so there's various things you can do, and you got to go look at the Beautiful Soup documentation. It could be a whole class on Beautiful Soup. So here's a thing you can do, is this object, you can sort of call it like a function and say, hey, give me back the anchor tags. And anchor tags, of course, are the tags that say href equals blah, 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 /a. So all of this is an anchor tag. And then we're going to loop through the tags because there could be more than one of those anchor tags in the file. And then we're going to pull out that href. And that's what this does. We're going to loop through all the tags and print out the href. So if you tell it to go to drchuck.com, it will show you the one external link in drchuck.com. And so I've got an assignment that sort of goes into that in some more detail. But this chapter has been a whole bunch of interesting stuff. We started with TCP/IP model and talked about sockets that are phone calls between computers. and then how applications, protocols are developed to say what we say on those phone calls. And we've explored then the HTTP protocol, which is probably the most likely thing you're going to see. And then we played with all this in Python and saw that Python is really good at this. You can write extremely simple and small programs to do some extremely complex and powerful things. And again, that's why people like Python, is because it makes the complex simple.
We're going to do a little bit of sample code. If you're interested in getting the sample code, you can download this zip here at pythonforeverybody.com, materials.php, and you will download and you will get all the files, and all the files that I'm looking at here. And so the one I'm going to play with today is the file called urllinks.py. So the first thing you got to do before urllinks.py works is you have got to install Beautiful Soup, and I've got some simple instructions at the beginning of the file. And so one way to do it is install it using Python install process to install this Beautiful Soup for all Python applications. And if you are the owner of your computer and you're going to use Beautiful Soup a lot, it's a fine idea to do that. But I want to show you a simpler way that if you don't own your own computer and you just want to make it so that Beautiful Soup works, you can download this file right here, Beautiful Soup 4.zip, unzip it, and put it in the same folder as here. And so if you look in this folder, I have a subfolder called BS4, and that's the unzipped version of this. And it has these things. I didn't write this code, so I'm sorry if the name is bad, but this is the code to BS4, and this is what's in BS4.zip, and it's in the same folder as urllinks.py. And so what happens is when you do this from BS4 import Beautiful Soup, that either can go to sort of this global magic place that Python installs stuff and pulls in the Beautiful Soup object, or it can go to the folder BS4 and pull it in. Okay? And so that's how that works. So you have to do one of these two things. I prefer to keep it simple, download and unzip this file and put it in the same folder as this code, and away you go. So from the previous example, we're going to use urllib, of course, and then we're going to pull in the Beautiful Soup. From the Beautiful Soup 4 library, we're going to get the Beautiful Soup object. Now, if you do this with SSL, if these websites we're going to play with have SSL, you pretty much have to do this little hack. And these 3 lines, don't worry too much about it. The whole idea, you can do Google on Stack Overflow and figure this out. But this is the way that you ignore errors when you have SSL certificate errors. And so we have to add this parameter context equals CTX, which is this variable that we create. So this part and this part sort of just do them. If you don't, you can take them out actually, but otherwise you won't be able to do HTTPS sites. So let's take a look at what we're doing other than dealing with the HTTPS problem. Going to ask the user for a URL. We are going to retrieve all the HTML. We're going to do a URL open, just like we did before. Now this would return us something we could loop through line by line with a for loop, but instead we're going to say, hey, read the whole thing. And that basically returns us the entire document at that web page in a single big string with new lines at the end of each line. And this is not an Unicode, but it's probably a UTF-8 string. But it turns out Beautiful Soup knows how to deal with UTF-8, and it also knows how to deal with Unicode strings. So what we're saying is Beautiful Soup, read through and deal with all the nasty bits, right? So HTML is like very, very flexible. So drchuck.com/page1htm. And so if we take a look at the source of this, view page source, make this bigger, you know, you might be able to do regular expressions, but it does things like break stuff across lines. There could be a line break here. There could be all kinds of things, right? And so writing, you know, regular expressions or splits or whatever is really hard for HTML. And so what we do is someone has written this. It's called Beautiful Soup. And it's basically, this is the code, and it's based on a joke from a children's story. it basically, someone has just went through and figured out all the bad things that could possibly happen when you're reading and parsing HTML. So either you use it or you will slowly but surely derive all the things that it doesn't work. And so when we look at this line right here, this line at a high level is saying, we're giving you ugly, nasty HTML that could make no sense whatsoever. Please read it and have all the brains that you have and all the weird stuff, figure that out for us and give us back an object. I happen to call it soup. You don't have to call it soup. An object, and that is a proxy for that HTML, but this soup object is clean. And so what we can do is we can sort of retrieve all the anchor tags. So we can talk to this object and say, ask it, give me the anchor tags. What's an anchor tag? Well, if we take a look at this source, the anchor tag is the A through the /A. That is the tag. It is the tag, it is attributes that are on the tag, it is the text within the tag, and everything. And so that's what we're going to get. Now, I called it tags plural, not because plural matters at all, but because we're going to get a list of tags. Because even though this web page has lots and lots of tags, if we look at, say, drchuck.com, and view source, well, that's kind of small. View page source, right? And we go look for anchor tags. We got 45 of them, and they all kind of have weird stuff in them, right? So this line will give us back a list of tags. It will give us all the tags in this document. So it goes, the tag goes from there to there. And then what we're going to do is going to write a loop to loop through all the tags. So that's basically hopping, like it's hopping through the document, sort of like this. That's what it's doing. Hop, 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 hop. And it's pulling out the text of the href attributes. So it's going to pull out this bit right here. Oh, whoops. Oh, darn. That was so cool, because that's a flaw. Look at that. This is my own page. There is no closing quote here, but it's going to work because HTML soup is like, oh, I know what to do about that. I can deal with that. So let's check to see if that one works, because that's like a mistake. But that's one of the things we like about Beautiful Soup. So we're going to read through, and then we're going to pull out all the hrefs. So this is probably thousands of lines of code that you really don't want to run. So Python 3 URL links.py. And so let's start with a simple one, http://www.drchuck.com. And it reads it. Oh, that's actually the card one, because we got a whole bunch. Let's see if the Sugi one worked. It found that one. It's right after sakaiproject.org. Where is that? Is there another Sugi? Oh, no, it didn't find that one. That's kind of funky. Look, it found it wrong. But that's okay. So you see it found all these and did a lot of nice stuff for us. If we do it, Python 3 URL links.py and do the easy one, http://www.dr-chuck.com, page 1.htm, we will only see one. And there we go. Now, the SSL is if you are looking at a page that has SSL, Python URL links to, so I'll go to like https://www.si.umich.edu, and that will get a bunch of links. And so you'll see, if it wasn't for that, so all kinds of stuff coming back, and if it wasn't for this bit right here and this bit right here, this HTTPS wouldn't have worked. And it's not that that website had a bad URL. It has a certificate that's not in Python's official list. And so the URL is okay. So that gives you a quick summary of using the Beautiful Soup library in Python along with the URL lib.
Hello and welcome to Chapter 13, Web Services. So what we've been doing so far is we've been using the request response cycle. We've learned about sockets, we've learned about URL lib, and we've actually learned how to pull HTML and even flat text off the internet. But what we're going to talk about now is using that same request response cycle to retrieve information that is specifically designed for programmatic consumption, so that, you know, we had to have this beautiful soup which sort of did a hack job or solve the hard problem of parsing HTML. But why not produce data in a format that makes good sense to a program, because programs want to talk to each other? If you recall, the whole idea of a socket is to have one application process sending data to another application process. And so if we think about this for a moment and we realize that we have all these programs, they could be written in different programming languages and they're all connected. And so they might want to send data back and forth through the network. PHP programs, JavaScript programs, Java programs. And so we have to decide on a protocol that is independent of any programming language. And we call that the wire protocol, because if you were to sort of take some connection and watch the exact characters that go back and forth, that's what you would see if you were monitoring the wire. So that's why we call that the wire protocol. And so the idea is that we have to agree on a format that is going to represent the data, and we can't make it a Python specific format or a Java format. And when we take the data from the internal representation, maybe a Python dictionary, to send it to the wire, we call that act serialization, and that is going from sort of the internal representation to the serial representation, or the wire representation. And then here is an example of a person with a name and phone number with using less thans and greater thans. This is an XML example. And then in the far end, in a different programming language, it receives this and then deserializes it, and then turns it into some useful structure inside that programming language. And so this is an example of a wire protocol that's using XML, and that's one of the formats we're going to talk about. Another format that we're going to talk about is a format called JSON, JavaScript Object Notation, and it is simpler and easier, but it's not as precise and descriptive as XML is. And so while you'll find that most of the things you run into, especially if you're talking to APIs of one form or another, you'll find that JSON is very common. XML still holds sway in places like documents. So if you look at docx at the end of a Microsoft Word document, docx means that it's an XML version of the representation of a word processing document. So the first thing we'll talk about is XML. So one of the two ways that we mark up data is XML, the other JSON. First we'll talk about XML. We'll talk about XML more for a longer time than we talk about JSON. XML stands for Extensible Markup Language. There was a number of markup languages in the 90s that were out there, ways to send data between computers. And none of them was like amazingly better than the other, but in the early 1990s, as HTML came out, the idea that we could use less thans and greater thans, you know, or angle brackets, some people call them. Once HTML made angle brackets popular as a representation format, it was pretty natural that we would find a data representation format that would take a similar approach. And so inside XML, we're going to talk about tags, we're going to talk about attributes, we're going to talk about data, and we've already talked about serialization and deserialization. Serialization is the act of taking data inside of a computer in one programming language, setting it up for transport, transporting it across, and then taking it back apart and turning it back into the data in whatever internal data it needs to be in the destination system. So here is some basic XML, so we can take a look at the various things that make up the XML. So it's very much like HTML in that we have tags, less than, greater than. The difference is we get to name the tags anything we want rather than the A tag or the P tag or the H1 tag. And there's a beginning tag and an ending tag, and they're bracketed together. And there's syntax errors in XML. Syntax errors in XML are more severe than syntax errors in HTML. It's supposed to be right, and if you send bad XML, it's likely that the far end will not understand it. So we have a beginning tag and ending tag, and so like name and slash name are a beginning and ending pair. Then there is the actual textual content, and that is the material between it. And then here's a phone and slash phone, and we have this thing called the attribute. Key equals value. The key doesn't have double quotes. The value always has double quotes, and this is like href equals on an anchor tag. And sometimes you have what's called a self-closing tag, where you don't actually have a closing tag. You have all the data that you need in the attributes, and so you don't even bother putting an empty text area in a closing tag. So that is a start tag, an end tag, attribute, and then a self-closing tag. Those are some basics of XML. In general, XML doesn't care too much about white space. It does in the text areas, so in here it matters and here it matters, but things like we can indent this a little bit differently, and we tend to indent it in a way to make it look reasonable. Although once you have programs sending it back and forth, they tend to send it more compacted just for efficiency purposes. So one of the concepts is that there is a hierarchical structure within an XML document, and there are parent nodes and child nodes, and you can think of these as simple nodes that is a tag and some data, or a complex element that has a tag that includes other tags, some child tags. And there's a couple of different ways we can take a look at this. The simple and more natural way to think about this is a tree with parent-child relationships. So here we have this A tag on the outside, and that's the top level one. You can only have one outer tag, and you can't have another tag down here. So you have to have one tag that's sort of the root tag for everything in this XML document, and it has two children. So the C tag and the B tag are two children. So the B tag is a child of A, and then C has a D and an E tag that are children there, and then the textual data we model as a child of each of those tags, and you'll see in a bit why it's best to do that. So that is the way to think about this as a tree, to represent that XML as a tree. If we add attributes to it, and this is where you kind of see why it's nice to take the text area and make that be a child of the node, an attribute is a different. So the text is a special kind of child, and you can literally have more than one attribute. You could have x equals 2, zap equals whatever, and these could have a couple of different attributes. The W attribute is a value of 5, and that's the 5 down there, and so you could have multiple ones. You can only have one text node. Now, in the case of A, you have a whole bunch of text nodes, but these are because there are child nodes. Within one simple node, you can only have one text element. You can also think of XML as paths, and the easiest way is to sort of look down this tree version and look at from the path from the parent. So you go to A, then the child B, and then X. So at position AB, you find X. So AB is the path up to the root. So ACD, that's this one, is the path to Y, and ACE is the path to Z. And so you can think of these as paths. Part of what we're doing is we're coming up with ways to walk through and parse trees of XML data. So the next thing we'll talk about is how we determine if a particular XML document is legal or meets the contracts that two applications have set up.
We're going to do a little bit of code. If you want to get your hands on the code, go to the materials website, materials.php, materials.php, and download the sample code. The code that we're going to work on today is the XML code, and we need to be able to talk XML to work with web services. And so here's one of the examples from the book. It's xml1.py. And so later we'll be pulling XML and JSON from the web, but for now we're just going to put it in a triple-quoted string, so data. And we're going to use a built-in XML parser in Python called element tree. And when we say import XML etree element tree as ET, this as ET gives us basically a shortcut handle for it. And so the idea, this is a string, it has less thans and greater thans. It looks like structured information, and it is. But really at this point it's only a string. Now we have to call this ET from string to read this and give us back a tree object. And what it does is this might blow up. This code might blow up right here if there was a mistake in it. Okay, and matter of fact, I can probably put a mistake in. Let's see if I can delete this and save it and run this code, and we'll see that it will blow up. Right? And so it blew up here in line 8. Element tree blew up, it blew up in line 12 of the code, which is right here. This failed because the line 8 of the XML string was wrong. So let's put that back in. So now it's properly formed XML. So this tree we get back, I name it tree just because I always name it tree, but you could name it X. So the key is tree.find goes and looks for a tag named find, and tree is no longer got less thans and greater thans in it. It is went and turned these into objects within objects within objects. So tree find name says I would like to find the tag name, and that's what this bit is right here. And then .text is going within that and grabbing that text, okay? And if we say tree find .email, then that's going to give us this, and then that's that object, and then .get asks for the contents of the hide attribute, which is the string yes, okay? And so if we run this, now that it's fixed, Python 3 xml1.py, it will pull in and get the name and the attribute. So it pulled the Chuck out, and so you get this object and then you kind of dive into that object. And so that's xml1.py. If you got a tag, you can either get the text out of the tag or you can get an attribute out of the tag. So now let's take a look at xml2.py. Again, we import element tree and we have a tag, and XML's always got to have a single outer tag. But this time we're going to have, in effect, a list. Now let's line this up a little better. There we go. That looks a little prettier. And so users, not the fact that it's users doesn't mean anything, but we often come up with semantically meaningful names for these things. Users is going to have as its children a list of user tags. Okay, so the children under user, user under user, and then this has each of these as a tag. So we want to parse this, and this is a common thing we want to do. You know, and so again, the first thing we do is we read the string to just take this. It's a triple quoted string going from here to here. And then we're going to, instead of doing find, which gives us one tag, we're going to do find all the users tag, the user tag that is a child of users. And we get back a Python list of the tags, not of the text, but of the tags. So there's a one tag, and there is another tag. And so we can do len of that, so we can see that we got two. And then we can write a for loop, and this item is going to iterate through the tags that are the user tags that are children of users. So the first time item is going to be this tag, a tag, remember, and then the second time it's going to be this tag. And so we can do things like find and get, just like we did with in XML1. So running this is not too exciting. Python 3 xml2.py. You see that there are two users. That comes from this print right here. There are two users in there. And the first one, if we go into name and we go find the text within the name tag within user, then we get Chuck, and then we get the ID, which is 001. So we find the ID within that item, and then we get the text, and then we look and we grab the X attribute off of that. And so we see Chuck 001 and 2, and then in the next tag the for loop continues, and we print that out. Okay, and so that's just a basic run through of the XML from the chapter in the Python book. Okay, thanks.
So now we're going to talk a little bit about XML schema. XML schema is a language that allows you to decide on whether or not a particular XML document meets a contract, an arrangement. So you have two pieces of software exchanging data using XML, and what if one of them, if they're all working, nobody really worries too much about it. But if all of a sudden one breaks, you change one side and the other one breaks, whose fault was it, right? Was it the side that got changed or the other side? And so you could argue. So what you like to do is, before you set up these arrangements between these applications, set up a contract. In a way, they're kind of like the RFCs are, except that their scope is between pairs of applications. And so it itself is XML, and it basically, what we do is we take an XML document and an XML schema contract, and then we either say that's good or that is bad. And that's called validation. A piece of software that validates XML when given a schema is called a validator. And so an XML document, here we have our little XML document, we're passing it to the validator, and then we have a schema contract, which is itself XML. It's kind of a particular kind of XML, that XS::complex type. That's just a tag Colon is a legitimate character for the name of a tag. Name equals person, that's just an attribute. And so XML schema is a particular format of XML that renders an opinion about what XML is supposed to look like. So there's a number of different XML schema languages. The one we're going to look at is one that's kind of came a little bit later, that's very common, called XSD, which is the World Wide Web Consortium's schema specification. Often you'll find files that have suffixes of .xsd that actually contain the XML, just like we're going to show you. So if you recall, there are simple elements which have text children, and then there are complex elements where other nodes are children of other nodes. And so we can say this. And so here we have a little bit of XML, and the XML schema that makes sense with that. So what we're saying is the outer tag of this legitimate XML is supposed to be a complex tag with a name of person. And so there we go. That looks good. Good, good. Then there is a sequence, and then there is a simple element, a name of last name, looks good, and it's a string, that looks good. Another tag that's of a named age that's of type integer, that's good. And then a thing that's called date born, and then there it looks like a date. So we check all these things, and we can basically say, yup, you know, that is a good XML document according to this schema. And you don't have to write this generally, but there is software that reads these two things and comes back with a true or a false, and might even have some detail as to what went wrong with this particular schema. Here's some more that you can do with a schema. We can do things like, you know, have a complex type, we have a sequence. Here we have a string, full name, and a string child name. But we have this min occurs and max occurs. So min occurs is the minimum number of times it can occur, and maximum is the maximum. So min occurs equals 1, max occurs equals 1 means it's required. And so this is required, and we don't have two of them. Two of them would be an error. One of them is fine, so that's good. Here the child name is min occurs 0, max occurs 10. So we have 4 here, and so that's good too. And so that is another kind of XML schema constraint that you can have. Here's a few other data types that we can do. We've done the string, we've done the date. The date looks like this. Dates are 4-digit year, 2-digit month, 2-digit day with dashes. Now there's lots of different ways to represent dates, but the nice thing about this, and you have to put the zeros in, so 09 for September. It means that these are sortable as strings, so that if you do all your dates this way, they're sortable as strings. So you could argue what is prettier, but for computers we don't worry about that. We're arguing about what's the most functional. And then the date time is that same date format with zeros, followed by the letter T, and then followed by hours, minutes, seconds, 0 filled, right? So 9 o'clock is 09. And then the time zone, which we'll talk about a second in the next slide. You can have decimal numbers and you can have integer numbers as well. And so we are able to sort of render an opinion as to what is good and what is bad in the resulting XML. So dates are kind of interesting. There's, again, we have lots of different formats of dates, 9, 10, 9/10/2002, right? That's a format of a date, but that's one. There's another format of the date, which is 12 December 20, whatever. And so this is how people show dates. Computers don't want to have all those different dates and don't want to figure those out. They have libraries that produce dates and make them look pretty and for particular locales, but computers really want dates that work best for them. So we just say, okay, we're going to have this year, month, day, time, and then 0 fill, hours, minutes, seconds, HMS, and then time zone. Now, computers even prefer a time zone. I don't know if you've used something like your Google Calendar and you take a flight or take a train trip and you end up in a different time zone, everything switches. And that's because Google Calendar is not really storing the time zone that it's not storing the dates relative in your current time zone. It's storing them in what we call universal time, or Greenwich Mean Time. Zulu time is another word for that. And Z means this time that is the time in London, England, Greenwich Mean Time, and And so the thing is that means if this data moves between time zones or crosses the international date line or standard daylight savings time or anything like that, none of that changes. And so we have this internal date and time that's very common in situations where computers are exchanging data that then gets shown with a time zone, converted to the time zone or the local format. That's the right way to do that. And there's a standard for how dates and times are supposed to look. So here's another little example of some stuff. Let's see what we got. Now, if you see this little question mark XML, that's not a problem. That just is a way of sort of putting a header on the whole document that says it's an XML document, telling it that's a UTF-8 document. And that's not really a tag. That's sort of like a marker on the file, so that you can put that there, but it doesn't harm the XML. The outer tag is this tag right here, XS:schema. And then what else we got? We got an address. We've got a string. We've seen all those. Here we have country, and we're going to have a restriction that basically says this is a simple string, but we're going to make it so that you have to list one of these 4 as the country code. And so here we are down here, and that's UK, and that's UK, and so that is valid XML. Another couple of examples here. Let's see, string. Max occurs unbounded. That means infinite number. There's no limit on the number. You can do that. Min occurs of 0. XS positive integer. We've seen integer, but you can also say it's got to be a positive integer. Decimal, we've seen that. And then use equals required is just another statement that you can make. I'm not trying to get you to the point where you can do XML schema. Just get you a sense of the kinds of statements that we can speak about when we're talking about what is and is not legitimate XML. So let's talk a little bit about how we might talk XML inside Python. And so, like most things that are in this extended part of Python, we have to import something. And so this is the name of a library, XML etree element tree. And then as ET, this ends up being a shortcut. So we don't have to type these long things. And so ET is the same as typing that. It's almost like a macro. Now, normally this XML is going to come somewhere from the network, but I'm just going to put this in a string. I'm using a triple quoted string, and so that means that this triple quoted string starts here and ends here, and all these new lines that are here are actually part of the string. So this is kind of like I opened a file and read the whole thing in. But just to keep this totally self-contained, I'm putting it in a string. So the XML would come from some server on the other side of the network. We would get this XML. So that's how it would normally work, okay? So this is the XML right there, and we parse a string of data, and we call ET from string. So we're passing in the less thans, the new lines, the greater thans, all of this stuff we're passing in. And this could have syntax errors in it. So this might blow up if this had a syntax error, like we forgot the little slash or something, there was a syntax error. But this doesn't have a syntax error. So then what we do is we get back an object. I just happen to call it tree because it kind of is like that tree version of the XML. That is an object that we can then query to pull data out of it. So we say tree.find and look for a tag name name. So that finds the tag name name is this. It's everything. It's the tag and the text. If we want the text, we add .text, and then that .text, that actually refines it to only the word Chuck. And similarly, if we do tree.find email, that tree.find email, that finds the email tag, which is this tag. It has a child attribute, and you can get any of the attributes. You say .get. There's only one text child, but there are many attribute children, and so you have to tell it which one you want. And so this bit right here, all of that will resolve down to that string yes. That's what you're going to get there, yes. And so you kind of build up these little finds and call methods. This is not clearly a full introduction to element tree, but you get the idea that you sort of dive down in with these methods that call methods to get little pieces out and parse all of that. Here is a different example. In this one, again, we're using triple quoted string, we always have a single tag on the outside, and then I have a complex type of users, and in it there are 2 user objects. So this is kind of like a list, right? So this is more than one of these things. So this user can occur more than one time. And again, we take this, we pass that into from string and get back an object that represents the name stuff. Does not necessarily have to be the same as this outer tag. Just a variable. This could just as be easily as X if I wanted. And so now what I'm going to say is, hey stuff, I want to find the tag, the path, users/user. I want to find all tags that match users/user. So that's going to give me a list of 2 tags, 1 tag, 2 tags in a list. Tag, tag. Oops. So 2 tags. Now I can print out how many I get. That'll be 2 in this case because I got 2 tags. And then I can actually iterate through the list. All right, so I can iterate through the list. So this item is going to iterate first to this tag, and that tag, now it's like in the previous example, we can look for the name tag within there and pull the text out. So we pull that text out, find the name tag, and then within that find the text. And we can find the ID tag and pull the text of that out. So that pulls out this 001, and I've scribbled too much. And then we can item, which is, this is item, is that whole tag, dot get X. So that gets the attribute, that gets the 2. That 2 comes down here. Okay, and then item goes to the next one because item is looping through, so item iterates down to that one and pulls out the name.text, the ID.text, and the attribute.x and pulls all those pieces out. So this is the basic pattern. You saw one where you're tearing into a single thing, and here you're tearing into something that is expected to occur more than one time. And so that's a quick summary of how you talk to XML in Python. Up next, we're going to talk about the other serialization format, JavaScript Object Notation. So now we're going to talk about the other serialization format, JavaScript Object Notation. Chances are good, as you go out there, you will very likely encounter more JSON than you will XML. Not that XML is bad. XML is better for rich and hierarchical documents, whereas JSON is best for just pulling data out of a system and moving it between 2 systems with the minimum of fuss. This is Douglas Crockford. I have a great interview from him. He's a funny guy, very, very smart. He claims he didn't invent JSON, he discovered it because it really is based on the literal notation for JavaScript. And it actually looks a lot like the Python literal notation for objects and for lists. Now, Douglas Crockford is quite a sense of humor. He wrote this book called JavaScript: The Good Parts. That's the little one right there. And then JavaScript: A Comprehensive Guide. And the sense of humor is all the stuff that's in JavaScript that's not too useful. And while this is sort of a tongue-in-cheek, it also is trying to say that JavaScript, what Crockford is really saying here is JavaScript is a great language as long as you avoid the tricky bits and sort of keep it very, very simple. And JavaScript is indeed a great language. But JSON comes from JavaScript. You can read about JSON at json.org. JSON is not an international standard. It's not like an RFC. It really is. Douglas Crockford decided to register json.org and typed in some pages, and people started reading it and people started using it. And partly that was because it was truly derived from the JavaScript JavaScript literal syntax. So we're all ready to code. Here is some Python that's going to process some JSON. Keep it straight. Python process JSON. So again, I'm using the triple quoted string here. Now you'll notice the syntax that we are using is not angle brackets, but instead curly braces. And so the curly brace, and then within the curly brace you have key value pairs, name, colon, Chuck, and the key, colon, value. And both sides have quotes. You can also have objects within objects, curly brace, key value pairs, key value, key value. Looks a lot like Python. And then you can do this. And so this is a structure that has one key value pair that's a string, another key value pair that's an object, another key value pair that's an object, and then these are key values within those contained objects. So this is a string that again probably was retrieved across the network from some other place, and we're going to pass that string into the JSON library load S. Load S stands for load from string. So it reads this, parses it, looks at all the white space. White space again doesn't matter too much here unless it's in between double quotes. The white space doesn't matter, and so it parses it and then returns us a dictionary. So the thing that's different about JSON is that its structure and representation are simpler than XML. So in Python, everything either comes back as a dictionary or a list, or a dictionary within a dictionary, or a list within a dictionary, but it's all dictionaries. It's not a separate structure that you have to do gets and finds and find-alls and lookups. So it's right there. So when we get this back, because this is a curly brace, info is a dictionary. And so we can just use the standard syntax of Python. Info subname. Well, that will bring, let's clear this. So info subname, we'll go find Chuck. So if you compare that with the XML, that's just a lot easier. Now, when we have info sub email, that's this thing. So info sub email is that thing. And then sub hide is this. So that's what comes out here. Okay, so it's really nested dictionaries and lists. We haven't seen a list yet, but this is a set of nested dictionaries that it parses. And it's equally simple in other programming languages. This is a little more complex version where the outer element is a square bracket, which means it's going to be a list. And so we have a list of 1, 2 things. So this is a list of 2 dictionaries. So there's 2 dictionaries inside that list. So again, we take this string and we load it into, use the JSON parser to read the string and give us back, in this case, info is a list. It's got 2 items. If we print out info, it'll give us 2. And we're going to iterate through. And so if we're going to iterate through, item is going to first be this, and then it's going to iterate to this. And it's going to print out item sub name, which is going to print out Chuck, item sub ID, which is going to print out 001. Now you'll notice that there is no attributes, and that's because JSON is simpler. But we can have the X, and it just is another item, so we say item sub X, and that's going to print the 2 out. And then it'll iterate to the next one, and it'll print out the same thing for those guys. And so JSON is simpler because you can't represent as complex a data structure, or you have to compromise and map it into a simpler data structure, but then it is lists and dictionaries, and so once you've got it parsed, it is easier to understand and to make use of. So that was quick. So that's partly why everyone likes JSON better, is once you have come up with a format that you're going to send it back and forth, it's easy to make it and it's easy to read it. Now what we're going to talk about is sort of moving up a level. If you've got all these data formats and URLs that you can hit to pull those data formats down, what approach do you do as you start to construct applications that increasingly go from a single application to a networked application?
We're playing with the web services chapter right now, and if you want to get the materials for this course, you can go here and download the sample zip, samplecode.zip. I've got this all sitting already on my computer. I also have the whole thing in GitHub if you want to get it out of GitHub. So the thing we're talking about now is we're talking about the JSON1.py example from the book. And so JSON is kind of like XML except a lot simpler. And that's why a lot of people like it. It's not that JSON is always better, but JSON is better in a lot of situations that don't require the complexity of XML. So we start to import JSON. JSON is built into Python, but we have to ask to import it. Again, we're using a triple quoted string to put the JSON in there. And JSON looks a lot like Python dictionaries, key value pairs, key value pairs. In this case, this is a key and the value itself is another dictionary. or in JSON terms, an object, but again, key value pairs within key value pairs within key value pairs. And all these little cursor guys have to, all these little curly brace guys have to line up properly. And so, like all the time, this is a string, which we normally would read and decode from the internet, but for now we're just going to have it in there. Load JSON.loads says go into the JSON library, pull out load string, and parse this, which turns